A 100 amp main log-only sub-panel is being installed in a remote building to serve a woodworking shop. The question is whether the 100 amp plug-in breaker located at the main disconnect can serve as the disconnect for the sub-panel. The answer is no, it cannot. The National Electrical Code, or NEC, mandates specific requirements for disconnecting means for sub-panels. These requirements are primarily based on safety and the ability to quickly de-energize a sub-panel in case of an emergency or maintenance. According to the NEC, a disconnecting means for a sub-panel must be located within sight of the sub-panel and readily accessible. This means that the person operating the disconnect needs to be able to see the sub-panel it controls, or it needs to be remotely operated in a manner that is safe and compliant. The requirement for being within sight is crucial for safety. If someone is working on the sub-panel, they need to be able to verify that the power is disconnected and that no one can re-energize the circuit without their knowledge. This prevents accidental electrocution or other injuries. If the main disconnect is not within sight of the sub-panel, it does not meet this requirement. The NEC also requires the disconnecting means to be located within the same building as the sub-panel. This requirement ensures that the disconnect is easily accessible to anyone in the building who may need to de-energize the sub-panel. If the main disconnect is located in a different building, it does not meet this requirement. In this scenario, the main disconnect is located at the main panel, which is not within sight of the sub-panel in the remote building. Therefore, it cannot serve as the disconnect for the sub-panel. A separate disconnect switch or circuit breaker must be installed near the sub-panel in the remote building to comply with the code. This disconnect switch or circuit breaker should be clearly labeled to indicate that it controls the sub-panel. The size of the disconnect switch or circuit breaker should be appropriate for the size of the sub-panel. In this case, it should be rated for at least 100 amps. The installation of the disconnect switch or circuit breaker should comply with all applicable NEC requirements. This includes proper grounding, overcurrent protection, and wiring methods. It is important to note that the NEC is a complex and constantly evolving document. It is always best to consult with a qualified electrician to ensure that your electrical installations comply with all applicable codes and regulations. In addition to the NEC requirements, there may be local codes or regulations that also apply. It is important to check with your local authorities to determine what these requirements are. By following the NEC and local codes, you can ensure that your electrical installations are safe and compliant. This will help to protect you, your family, and your property from electrical hazards. To further elaborate on the importance of having a local disconnect for a sub-panel, consider the following scenarios. Firstly, during maintenance or repairs, a local disconnect allows the electrician or homeowner to safely de-energize the sub-panel without having to run to the main panel, which may be located in a different building or a significant distance away. This saves time and reduces the risk of accidents. Secondly, in the event of an electrical fire or other emergency, a local disconnect allows first responders to quickly de-energize the sub-panel, preventing further damage and protecting lives. If the disconnect was located remotely, valuable time could be lost in locating and operating it. Thirdly, a local disconnect provides a convenient way to de-energize a sub-panel for routine tasks such as changing light bulbs or working on equipment connected to the sub-panel. This eliminates the need to shut down power to the entire building. Now let's delve deeper into some of the specific NEC articles that address sub-panel disconnects. While the exact article numbers may vary depending on the edition of the NEC, the general principles remain the same. One relevant article is typically found in the section covering feeders and branch circuits. This article specifies the requirements for disconnecting means for feeders, which includes the feeder supplying a sub-panel. It typically requires that the disconnecting means be readily accessible and capable of being locked in the open position. This lockable feature is important for safety, as it allows someone working on the sub-panel to prevent the circuit from being accidentally re-energized. Another relevant article is usually found in the section covering panel boards. This article specifies the requirements for the overcurrent protection of panel boards, which includes sub-panels. It typically requires that each panel board be protected by an overcurrent device such as a circuit breaker or fuse that is sized appropriately for the panel board's ampacity. This overcurrent device serves to protect the panel board and the circuits connected to it from overloads and short circuits. In addition to these specific articles, there are other general NEC requirements that may apply to sub-panel installations. These include requirements for grounding, bonding, wiring methods, and overcurrent protection. It is important to carefully review all applicable NEC requirements before installing a sub-panel to ensure that the installation is safe and compliant. It is also important to consider the specific requirements of the equipment that will be connected to the sub-panel. Some equipment may require dedicated circuits or specific types of overcurrent protection. These requirements should be taken into account when designing and installing the sub-panel. When selecting a disconnect switch or circuit breaker for a sub-panel, it is important to choose a device that is rated for the appropriate voltage and amperage. The voltage rating of the device should be equal to or greater than the voltage of the circuit supplying the sub-panel. The amperage rating of the device should be equal to or greater than the ampacity of the sub-panel. It is also important to choose a device that is listed by a recognized testing laboratory such as Underwriters Laboratories or UL. This listing indicates that the device has been tested and meets certain safety standards. When installing a disconnect switch or circuit breaker, it is important to follow the manufacturer's instructions carefully. This will help to ensure that the device is installed correctly and that it will operate safely. It is also important to use the proper tools and equipment when installing the device. This will help to prevent damage to the device and to ensure that the installation is safe and reliable. After installing a sub-panel, it is important to test it to ensure that it is working properly. This includes testing the disconnect switch or circuit breaker to make sure that it properly de-energizes the sub-panel. It is also important to check the voltage and amperage of the circuits connected to the sub-panel to make sure that they are within the proper ranges. If any problems are found, they should be corrected immediately. Finally, it is important to keep a record of the sub-panel installation, including the date of installation, the location of the sub-panel, the size of the sub-panel, and the ratings of the disconnect switch or circuit breaker. This record will be helpful for future maintenance and repairs. In summary, the NEC requires that a sub-panel have a disconnecting means that is located within sight of the sub-panel and readily accessible. This requirement is based on safety and the need to quickly de-energize the sub-panel in case of an emergency or maintenance. The main disconnect located at the main panel does not meet this requirement. Therefore, a separate disconnect switch or circuit breaker must be installed near the sub-panel in the remote building to comply with the code. This disconnect switch or circuit breaker should be clearly labeled to indicate that it controls the sub-panel. The size of the disconnect switch or circuit breaker should be appropriate for the size of the sub-panel. The installation of the disconnect switch or circuit breaker should comply with all applicable NEC requirements. By following the NEC and local codes, you can ensure that your electrical installations are safe and compliant. This will help to protect you, your family, and your property from electrical hazards. This information is for educational purposes only and should not be considered as a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. Let's now expand on the practical aspects of selecting and installing a suitable disconnect for the 100 amp sub-panel in the remote woodworking shop. Firstly, consider the type of disconnect. The two most common options are a fused disconnect switch and a circuit breaker in a suitable enclosure. A fused disconnect switch provides both a disconnecting means and overcurrent protection, while a circuit breaker only provides the disconnecting means and requires a separate overcurrent device upstream. For a 100 amp sub-panel, a 100 amp rated disconnect switch or circuit breaker is generally appropriate, but it's crucial to verify this based on the actual load calculations for the woodworking shop. Oversizing the disconnect slightly is permissible, but avoid significantly oversizing it, as this can create other issues. Secondly, the enclosure for the disconnect switch or circuit breaker must be appropriate for the environment. Since the woodworking shop is in a remote building, the enclosure should be rated for outdoor use if the disconnect is located outside. An M3R enclosure is commonly used for outdoor applications, as it provides protection against rain, snow, and ice. If the disconnect is located inside the woodworking shop, An M1 enclosure is typically sufficient, but consider an M4 or 4X enclosure if the environment is particularly dusty or damp. Thirdly, a location of the disconnect is critical. It must be within sight of the sub-panel, meaning that the operator can see the sub-panel from the location of the disconnect. The NEC doesn't specify an exact distance for within sight, but a good rule of thumb is to keep the disconnect within 50 feet of the sub-panel and ensure that there are no obstructions blocking the view. The disconnect must also be readily accessible, meaning that it can be easily reached without having to climb over or move obstacles. Fourthly, wiring and connections are crucial for a safe and reliable installation. Use appropriately sized conductors for the 100 amp feeder based on the NEC ampacity tables such as table 310.16. Copper conductors are generally preferred for their conductivity and corrosion resistance, but aluminum conductors can be used if properly sized and terminated. Ensure that all connections are clean and tight, and use appropriate connectors for the type and size of conductor being used. Torque all connections to the manufacturer's specifications. Fifthly, grounding and bonding are essential for electrical safety. The sub-panel must be properly grounded to the grounding electrode system at the remote building. This typically involves connecting a grounding electrode conductor from the sub-panel to a ground rod or the grounding electrode. The sub-panel enclosure must also be bonded to the grounding conductor to ensure that it is at the same potential as the ground. Sixthly, labeling is important for identifying the disconnect and the circuits it controls. Clearly label the disconnect switch or circuit breaker to indicate that it controls the 100 amp MLO sub-panel. Also, label each circuit breaker in the sub-panel to indicate the equipment or area it serves. Seventhly, inspection and testing are crucial after the installation is complete. Have a qualified electrical inspector inspect the installation to ensure that it complies with the NEC and local codes. Test the disconnect switch or circuit breaker to verify that it properly de-energizes the sub-panel. Also, test the voltage and amperage of the circuits connected to the sub-panel to ensure that they are within the proper ranges. Finally, documentation is essential for future reference. Keep a record of the installation, including the date of installation, the location of the sub-panel, the size of the sub-panel, the ratings of the disconnect switch or circuit breaker, and the results of the inspection and testing. This information will be helpful for future maintenance and repairs. Remember that this information is for educational purposes only and should not be considered as a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. Now, let's discuss some potential issues that might arise during the installation of the sub-panel and its disconnect, and how to address them. Firstly, voltage drop can be a concern, especially if the remote building is a significant distance from the main panel. Voltage drop occurs when the voltage at the sub-panel is lower than the voltage at the main panel due to the resistance of the conductors. Excessive voltage drop can cause equipment to malfunction or overheat. To mitigate voltage drop, use larger conductors or consider installing a transformer to step up the voltage at the main panel and step it down at the sub-panel. The NEC provides guidelines for acceptable voltage drop in branch circuits and feeders. Secondly, ground faults can be a dangerous situation. The ground fault occurs when a live conductor comes into contact with a grounded surface, such as a metal enclosure. This can cause a large current to flow through the grounding system, which can be a shock hazard. To protect against ground faults, use ground fault circuit interrupters, or GFCIs, on circuits that serve receptacles in the woodworking shop. GFCIs will quickly de-energize the circuit if a ground fault is detected. Thirdly, arc faults can be a fire hazard. An arc fault occurs when an electrical arc forms between two conductors or between a conductor and a grounded surface. Arc faults can generate high temperatures that can ignite nearby combustible materials. To protect against arc faults, use arc fault circuit interrupters, or SIs, on circuits that serve lighting and receptacles in the woodworking shop. A SIs will quickly de-energize the circuit if an arc fault is detected. Fourthly, overloads can damage equipment and wiring. An overload occurs when a circuit is carrying more current than it is designed to handle. This can cause the wires to overheat and melt, which can lead to a fire. To protect against overloads, Use appropriately sized circuit breakers or fuses on each circuit in the sub-panel. The size of the circuit breaker or fuse should be based on the ampacity of the conductors and the loads served by the circuit. Fifthly, short circuits can be a serious hazard. A short circuit occurs when a live conductor comes into direct contact with a grounded conductor or another live conductor. This can cause a very large current to flow, which can damage equipment and wiring and cause a fire. To protect against short circuits, use appropriately sized circuit breakers or fuses on each circuit in the sub-panel. The size of the circuit breaker or fuse should be based on the interrupting rating of the equipment and the available fault current. Sixthly, improper wiring can lead to a variety of problems. Improper wiring can cause equipment to malfunction, overheat, or even cause a fire. To ensure proper wiring, follow the NEC guidelines carefully and use appropriately sized conductors and connectors. Also, make sure that all connections are clean and tight. Seventhly, lack of maintenance can lead to problems over time. Electrical equipment requires periodic maintenance to ensure that it is operating safely and reliably. This includes inspecting the wiring, connections, and circuit breakers or fuses. Also, it includes cleaning the equipment and tightening any loose connections. By performing regular maintenance, you can prevent many problems from occurring. Finally, remember that electrical work can be dangerous. If you are not comfortable performing electrical work yourself, it is best to hire a qualified electrician. A qualified electrician will have the knowledge and experience to perform the work safely and correctly. They will also be able to identify any potential hazards and take steps to mitigate them. This information is for educational purposes only and should not be considered as a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. And always remember to prioritize safety when working with electricity. Always turn off the power before working on any electrical equipment, and always use appropriate personal protective equipment such as safety glasses and gloves. By following these safety precautions, you can reduce the risk of electrical shock and other injuries.